So hello guys, welcome to the Mastermind YouTube channel. Previously I uploaded some videos related to web application development in Visual Studio, but there are lots of content available on YouTube regarding same, and I was willing to share or create a content which should be unique and which should be useful for each and everyone who is in the development, who is in programming, coding in this field, IT industries. So, where complete IT industries follow, most men or lots of people hit one website for um, whenever they stuck with any questions. So, which is a Stack Overflow. Stack Overflow recently sold on the price of 1.8 billion something. That was a recent news regarding Stack Overflow. So, come back to the topic. The, I'm creating a video series which will each and every video series will contain one question from the Stack Overflow website, and I'll take best answer from the number of answer for the posted question, and I'll explain or I'll try to explain those answers to you. That will be in the expecting or in the hope of that will be help anyone or should be a beneficiary for anyone in the programming field. So stay tuned, and that's also planned. Hope this idea will create some impact and you like my channel or my content as well. Please give your suggestion, your thoughts, what how can I improve in this process. So let's start. So first question I choose, uh, which is have a highest number of votes on the Stack Overflow site, which were asked 8 years before. Maybe it won't be a relevant, it might be relevant in the current development or development environment. So let's read a question. What is the question? Why pros why is processing a sorted array faster than processing an unsorted array? Okay, fine. So question is related to the data structure array, and we know that the some one of the operation on the array is sorting the array. So question is on uh, why the processing on a sorted array is faster than processing on the unsorted array. Okay, as a programmer, when we think that with sorted array is always good to deal with, that's why it's very new answer for this question. But trust me, this is not that much simple. Uh, I usually don't. I decided to don't mention the name of the questioner or the one who gives an answer, but this is pretty much interesting question. That's why uh, it will be good to mention his name. What is Jimanik G? I don't know what how to pronounce it, but yeah, Jimanik G. And the answer I choose for this is answer by Mastical. Okay, Mastical and Peter Coder modified it. Okay, fine. Okay, so sorry for if I mispronunciate those names. Okay, so let's start. What is the let's start with the question in brief. Here is a piece of C++ code that shows some very peculiar behavior. Some for some strange reason, sorting the data miraculously make a code almost 6 times faster. Okay, fine. So yeah, the question is on the C plus with the reference of C++ code. So let's go through the code. So Header files are included. Main file generate the data. What I can see is that constant unsigned array with the size 32 and blah blah blah. Then integer data of the array size. Yes, okay, fine. So unsigned C is initialized to 0 and it will be iterate till array size 32,768 and pre-increment on C and data, some random data is dumped into the data array. Okay, so with this the next loop run faster. So what he did, he sort an array. Okay, using the function sort. Fine. And then he test with he created a clock and again he iterating a loop through loop by declaring unsigned I is equal to 0, I is less than and pre-increment. And again for loop, inner for loop, which is starting from the 0 and it will iterate till array size the same as above. And the primary loop will be checking condition if the data is greater than 128, then perform a addition. Okay, fine. Then after he calculated the time, and then he printed a time and the some variable value. Okay, fine. So without a sort function, the code runs in 11.54 second, and with the sorted data, the code runs in 1.93 second. Oh, it's huge difference. Trust me, yeah, it's huge difference. I agree with man. Okay, initially I thought it might be just a language or compiler anomaly. Yeah, so I tried Java. Okay, fine. I don't know why Java, because C++ is most faster than Java. What knowledge I have regarding programming with the 5 years of experience. Okay, fine. Uh, so I tried with Java. Okay, fine. So he declared a Java and Java class is the public main. Uh, Public static void main. Okay, the code is same, the syntax is just different as it is in Java. Okay, fine. And the same operation and same is printed, difference, time required and the summation with the similar but less extreme result. Okay, fine. My first thought was, so he don't find any difference between the C++ and Java code. Fine. My first thought was that sorting brings the data into the cache. Okay, fine. But then I thought how silly that was, because the array was just generated. Yeah, I agree. So he's trying to say that that might be a possibility that arrays can get cached. But as array uh, array is just generated, so cache comes into the picture when data is from your hard disk, right? And in the running program, it will be always on the RAM, or the near the oh you must have uh, this is a different topic, the cache on the RAM and the data, the communication between the physical storage and the random access memory, how it is get copied or get roll on the RAM. So that is a completely different topic. But yeah, I agree. There is no cache comes in the picture, as I can see in the code. Okay, fine. So what's going on? What is the processing a sorted array faster than processing an unsorted array? Okay, so we got the question. The code is seeming up some independent terms, so the order should not matter. Yeah, I agree. So she also give related some topics, some questions. We'll look later. actually those are also I opened it for you. Those are also meaningful for the current age programming. But let's answer this question, which was asked almost and 8 years before. Keep in mind, a compiler 8 years before are completely or in major quantity as different from by the compiler running in today's. Yeah. So we'll read some comments for the record. Your data need not to be sorted, only partitioned, which is much faster operation. Ah, I think this comment question is different. I don't think this comment is answering for it. Another observation is that you don't need to sort an array, but you just need to partition it with the value 1 to 8. Sorting is n to log n, whereas a partition is just a linear. Okay, basically it is just one run of the quick sort partition step with the period chosen to the entity. Unfortunately, in C++, there is a just nth element function which partition by position, not by value. Again, this is different topic. I think question is different. The question is very straightforward. Why data structure of array sorting and unsorted with the piece of code is giving a huge amount of difference execution. Simple. One should be tagged with this question is that uh, then should must be tagged a compiler or the processor. Yeah, Java, C++, performance, CPU architecture, and branch prediction. Okay, CPU architecture can be a valid tag. In this case, it should be present. So, okay, so let's go to our answer, which having huge number of votes, and yeah, you are a victim of branch prediction fail. So, what is branch prediction? Let me tell you in simple language. It is a broad topic, but I'll tell you where branch prediction comes into the picture. So this is the code if condition while data and the array is greater than 1 to 8. Here a branch prediction takes a place. So what is branch prediction? Let's see. It might be explained in this answer, or if not, then I'll tell you. So yeah, it is explained. What is branch prediction? Consider an railroad junction. Oh, so beautiful picture is posted here. So uh, um, I don't I don't want to get into the reading line by line answer. So I already read that. So I'll explain in the short. So consider this rail lines, or what he said is the railroad. Okay, fine. So when train comes and you are the operator over here, which will switch between these two lane and decide on which path train should go. So what you will do? So as an operator, so the first assumption was the whatever the scenario is taken into the answer, and I'm just explaining that. So the person here, he will wait till the train arrive. Then he'll ask to the driver of the train and uh, which path he would like to take or he's willing to go with. And then after, as per the answer from that uh, train driver, he'll switch the path, right? Okay, fine. So what will be the next situation? A train operator will switch a path on on the basis, if it is an experience and uh, he saw a train multiple time pass from this route and he choose route B, then he'll not wait for the uh, our train arrival, or he will not wait till the answer from the train driver. He'll directly switch part to the uh, B lane, and train will go with that lane only, because last few of attempts train choose the lane B to go with, right? So operator assume that okay, this time train will go with the B path, as it was went on the B path last time. Clear? Okay, so fine. What if I think mhm, connection goes. Okay, fine. Uh, so yeah, so second scenario was whenever the operator is right, then there won't be any issue. But if operator is wrong and instead of choosing path B, train driver want to choose the straight path, path A, and go with that, then that time, as operator already switched for the path B, train driver realize when he move ahead with the lane B, then what he'll do, he'll stop the train, he'll backtrack, he'll come at the point of operator switch the train rules and train lanes, and then he shout on that operator and say, hey, I want to go with the path A, you switch a wrong path. And then again, operator will switch path to the A as per the instruction from the train driver, and the train will move forward with the path A. So there are plus point and disadvantage as well with each and every scenario. If operator is waiting till train arrival and then asking for to the train driver which path he want to choose, there is a delay, there is a time, so right. And if so, it will be a one by one execution. Okay, and if we choose advance and switch path to the B as the previous iteration of the train or previous occurrence of the trains from, as it choose the path B always in last few attempts, so operator switch that path, and it will be only beneficial if it is right. If it is wrong, then again the cost of backtracking, again wait till the switch to the path A, and again it will move ahead, so it will include a cost, right? So this is what a branch prediction, and this is what the same operator type of activity is happen here on the if statement. Okay, so what is the statement here? It is the point where operator need to switch a path for the train. In programming, if condition is the place where compiler or the process need compiler or, or the processor or what processor needs to decide that a process should go to execute this or not. So that was the expectation. In this case, the compiler is playing a role of operator along with the processor, right? And the process of the running piece of code is our train. Hope I am clear with this. So if statement is the main main issues of causing uh, a time consuming or a tedious job which compiler or processor must have to handle with. Okay, fine. So this is what explained over here, and considering an state with at the processor level, it's a branch instruction, right? Okay. So the same thing is explained here. Here, this is our if condition, and this is our the expected perform task with the satisfaction of the if condition. Here is a similar as a here is a transformation of translation of this CPP code into the assembly code, and here we can see that. Um, Branch prediction is taking place, and processor is deciding how to process this or not to process this, right? So you are the processor and you see a branch. You have no idea which way it will go. What do? You halt the execution and wait until the previous instruction are complete, then you'll continue down the correct path. Right. The exact scenario which is explained in the train condition above. Okay. So in modern processor are complicated and have long pipelines, so they take forever to warm up and slow down. So warm up and slow down the terms which is what I can how to explain. Okay, warm up. So while executing any instruction on the processor, before that, while executing the instruction on ongoing in the memory or in on RAM, processor also preparing uh, next instruction or the data required for the next instruction. So that is simple language called a warm up. Okay, fine. So is there a better way? You guess with the direction the branch will go. If you guess right, you continue the execution. Okay, fine. So on the if condition, if you guess yes, I need to execute the condition, then and if you are right, then the execution will be great. If your case is wrong, then you'll need to flush the pipeline and roll back to the branch, and then you can restart down the other path. Exactly same as our operator and train driver communicating when the path chosen was wrong with the help of backtracking. Okay, fine. So if you guess the right time everywhere, the execution will never have to stop. Okay. If you are always choosing a path B, which is a right, then there is no need to stop off the engine and getting to backtrack and lots of operation before proceeding on the correct path. If you guess wrong too often, if you guess always a B and you must have to choose A path frequently, then obviously you spend a lot of time styling, rolling back and restarting. So, okay, this is the branch prediction. I admit it, not the best analogy since, okay, he's trying to say that trend is not a good example as there are lots of things going on the processor and in compiler, but I think this is a pretty much good example to explain what how to answer exactly to the point to the question. Okay, so how would you strategically guess to minimize the number of times the train must back and go down the other path? You look at the past history, correct? So let's again come to the code. Okay, yeah, we already have code. So first time I check as my data is sorted, correct? Uh, when my data is sorted, then my branch prediction will be always right till the half of the time, at a particular point of the time, right? Till I arrive with this condition satisfied, my loop always went to this path addition in the sum variable. At one point, my condition is not satisfying. That case only I need to roll back and I need to check again and I'll choose a path A. Okay, fine. So path A won't be having a summation. And then after compiler or processor will remember that, okay, now from this state it choose next path is skipping the summation operation, and then it will carry forward the same till the next wrong prediction happen. In this case, no wrong prediction happened and the flow went so smooth that it will reduce the time in the case of sorted array. Yeah, I think it's if we still have a doubt, then please do comment and let me know. I'll happy to answer you in comment section as well. Okay, fine. So uh, in others, you're trying to identify the pattern, follow it. Just I explained. It's identify the pattern. As hint from the above, the culprit is the if statement. That's it. We are done with that, and I hope we got the answer why the sorted array is more efficient or took a less time compared to the unsorted array. So let's take with the unsorted array. If in the unsorted array, if that condition is satisfied in the first time and it again not satisfied for the next iteration, then again rollbacking will happen. Again, trend errors back into the current position and ask the operator, "No, this is not the right path. Give me a right path." Then A is the right path. In next iteration, operator will decide that okay, last time it took a path and okay, it will be a right for this iteration as well with the help of the history. But next time again the condition changes as unsorted array is there. Might be the value is bigger than 120 or less than 128, and this will happen. And okay, so whatever I just explained that what happened with the sorted array, it is explained here, and what happened with the unsorted array, it is explained here. So in the case of unsorted array, in what we can say in the one line that completely random behavior and impossible to predict. And in sorted array, we can easy to predict that. Yeah, I'm sure the number of iteration will be right as my array is sorted. Yeah, hope I'm clear on this point. Uh, so what what can be done if the compiler isn't able to optimize a branch into the conditional move? You can try some hacks if you are willing to sacrifice readability of performance. Replace this with the this. Okay, fine. And the elements the branch and replace it some bitwise operation. Okay, so what is happening over here that yeah, we are eliminating uh, eliminating if condition in with the help of the bitwise operation. So how we are going to achieve this? You must have to familiar with the bitwise operation. So bitwise operation generally help uh, to optimizing our any arithmetic operation uh, on high level of arithmetic operation on the uh, data we have. So yeah, so note that this hack is okay. So we are not pretty much interesting in that. What So here is explained the core i7 and visual 2010 x64 release. So here some number is given: branching random data, sorted data is so less random data, and sorted data. So in easy language, what I can say that with whenever the branching is used by my processor or my compiler, it will have a huge impact when the data is sorted or data is not sorted. But with the branchless, it is exactly almost same. Like you can see that 2.56 and 2.58. So with the sorted and random data, with the branchless giving exactly the same result here. So with this, on the basis of this, our this question is depend. It is again asked by one Stackoverflow genius from this on the basis of this question, which is asks okay, which is just 3 months ago. Okay, fine. And why is the processing an unsorted array same speed as processing a sorted array with modern x86 and 64 select? So these both questions are pretty much contract in the contradiction of each other, as one is saying that sorting and unsorted array are giving a huge difference between the time required, and here why the processing of sorted array is same speed, speed in the sense of time, here is trying to say that. And so what is his observation that with sorted and unsorted array, with considering all the operations running on the CPU by killing all the operation on the CPU, releasing all the load and keeping all the load same while executing processes same time. So he took care of all those things, and he found the result are very similar in the modern architecture of the CPU, so what we can say the processor. So yes, current processor not relying on the branch prediction heavily. Before that, it was heavily dominated by the branch prediction techniques. But now there are lots of factors comes like vectorization, like unrolling. Uh, okay, so uh, those type of so what I can say, the processor are improved. So the question was, that's why I earlier mentioned that the question is asked before 80 years, it might be relevant nowadays or not. So if you are using a modern days CPUs or modern day processor, then this won't be the case, as this was the loophole in the it was a old technique to handle the um, branch or handle the some conditional or decision point of uh, flows in your program. And nowadays the processors are too advanced and there is a huge amount of scope. Then might be after some years, you can found a new question on that, and you will find exactly similar speed instead of a minor difference. We can't say that, but yes, a huge scope is there to improve this operation from current architecture, with the current architecture of the processor as well. So the straightforward question, answer for this question is that why processing a sorted array are faster than processing unsorted array. So it's completely depend on the processor, and there are more points in the coding if we go at the code level, and how I'll explain you later. But the key point is here branch prediction and branchless implementation. So 8 years ago, processors are heavily using a branch prediction, and nowadays it is not much rely on the branch prediction. We can say that it is uh, nearly a down to almost we are not using a branch prediction. Yeah. Okay, so what we are using if you are not using a branch prediction? uh, so yeah, so this is again the Peter code he'll come again to help us and explain these things. So Nat Legrage is here. So what he said that several answer to this question, you link and rewriting the branches was avoiding the branch prediction issue. That was an updated. Okay, fine, no issue. Especially C language understands. So means optimization O3, O2. There are lots of type of optimization. You can go into the debugger of the Visual Studio and you can find the with the C++. We can find the optimization or options over there. So vectorized is one point, and loop unrolling is another point. So what is vectorizing? Vectorized. I'll just give one example you of the vectorize, and hope it will enough to clear. So this is approach which we which the new programmer uh, learn with for loop, learn with this simple type of coding. A for loop from 0 and some number and plus plus, then some multiplication operation, and it is stored into the C array. Okay, fine. So what we call is a scalar. Okay, so an example would be a programming to multiply two vectors of numeric data. A scalar approach would be something like that. So what we call this a scalar approach. And what is a vectorized approach for the same code is for loop, no doubt in that. But look at here. See, I colon I plus 3. A I colon I plus 3 into B I colon I plus 3. Okay, so what is that? It will take a group from 0 to 4. Again, it will take a group from 0 to 4, and it will perform the addition of all the elements from this range in just one hit of instruction. So with a single line of execution of these, it will adding a bunch of 4 elements in the array. So while next iteration we must need to increment our I by 4, and it will again take next 4 bunches. This is what a simple explanation of vectorize. This is a very broad concept. You must need to study it well, but this is what it is. There is one more concept comes into the picture is loop unrolling. I'll also explain the same in the short example. Okay, so what is the loop unrolling? Here is a loop which is iterate hundreds of times. How we can improve that? Look at here. What we did in the vectorize, we are doing a similar thing or near close to the similar thing to it. we are iterating 100 times, but it on each iteration we are performing a operation with a 5 element, right? So with a single iteration we are what what we are doing, we are simply performing multiple operation in just one block. A procedure in the computer program is to delete 100 items from a collection. This is normally accomplished by means of a for loop which calls a function delete item. This is a part of the program is to be optimized, and the overhead of the loop requires significant resource compared to those for the delete function. Unwinding can be used to speed it up. As a result of the modification, a new program has to make only 20 iterations instead of 100. Right? How? Divide 100 for 5. I think it is 20. Okay, fine. So only 20% of jumps, conditions, and branches need to be taken, and repeats over many iterations, a potentially a significant decrease in loop administration overhead. Okay, so what we achieved through this loop unrolling, we achieve or we reduce a branch prediction, where branch prediction comes 100 of times, it comes only on 20 times in this case. So this is again a very lovely topic. You can go with this Wikipedia, and we also read for some books on it. And yes, this is all about the question: why is processing a sorted array faster than processing a sorted array 8 years before? And now the same question is why the processing of sorted and unsorted array with the same speed. So yes, it is enhancement in the compiler, enhancement in the processor, and yeah, the technique used for uh, processing an instruction at VFP force is pretty much different than what we do in current days, what processor do in current days. Hope my explanation helped you to understand the answer and this question as well. And questions change day by day. What we learn and answer for that particular questions might be similar or different. So yeah, this is what a life is all about. Okay, let me know if you have any suggestion for this. This is the first attempt for on the Stack Overflow. This is pretty much a big video. I am just expecting to create a video of 20, 10 to 15 or 20-minute max. But this was a very interesting topic, and I love to start with that, and that's why it took a huge amount of time compared to what I planned to serve you with only in 20 minutes. So I'll take care of that. I'll choose and I'll try to cut it down my explanation on the point, and hope you get best with the minimal time. If you have suggestion, please do in comment and let me know. Thanks for your watching. Thanks for your time. Like, subscribe. It's your choice. Bye bye.